continuous functions. So first we're going to figure out domains of lines. So a line is just a drawing of the x-axis, so that's why it's only domain. So draw yourself a number line. All right, and so on our number line we have points at -1, 1, 2, 3, and 5. And when we write our domain, we write it with these squigglies. Remember, domain is x values. And we just list the points on the line. So -1, 1, 2, 3, and 5. And this is discrete. So we're going to say, is it discrete or continuous? It's discrete because it's discrete points. A discrete function is just points. So that's why I always draw discrete with like a dotted line under it. So here's our next number line. And we have a closed circle from 1 to 5 with a line in between. So that's an and inequality if you remember from the last unit. So our domain is going to be an inequality with x in the middle, arrows to the left, 1 on the left, and 5 on the right. The smallest number on the left, biggest number on the right. So this is going to be continuous because it's a like full line. It's not points. So now let's talk about graphs, like big graphs, x and y graphs. So a linear function, y equals 5.95x, represents the cost y in dollars of x tickets for a museum. Each customer can buy a maximum of 3 tickets. So we want to know if the domain is going to be discrete or continuous. So you kind of want to ask yourself, can I buy portions of a ticket or is it just one ticket at a time? Since you can only buy one ticket at a time, it's going to end up being a discrete function. An alternate example of that would be like a candy bar. Can you eat a portion of a candy bar? Yeah, you can have like a certain percentage of a candy bar. But with tickets, you can't like just go to half of the show or half of the museum walk and then leave and just pay half price. Like that doesn't work that way. So that makes this a discrete function. So the only numbers of tickets we can buy are 0, 1, 2, or 3. We can't buy anything in between. Therefore, this is discrete. So now let's write the domain, and the domain is going to be the inputs, so the number of tickets, or the x values. So we're going to list off 0, 1, 2, and 3 with our squigglies around them. So now we're going to graph the data for the function, the discrete function. So we should just have points. We should not be drawing a line through our points. So the x-axis is going to be tickets. The y-axis is going to be the cost. And so we can either buy 0, 1, 2, or 3. 0 tickets is going to cost $0. 1 ticket is going to be $15.95. 2 tickets is $31.90. Let's see. So we have the point 0, 0, 1, 15.95, 2, 31.90, and 3 would cost you 47.85. So the last part, we're going to write the domain, or sorry, the range. So that's going to be our y values. So that's going to be a list with our squigglies around it of 0, 15.95, 31.9, and 47.85. Now let's graph a continuous function. So a cereal bar contains 130 calories. The number C of calories consumed is a function of the number of B bars eaten. So we want to know if it's discrete or continuous. This is continuous because you can eat a portion of a candy bar or of a cereal bar. So there's a tiny bite and there's like a medium-sized bite. Or you could leave crumbs, that's a small part left. And that's like the definition of a continuous function is you can have any number in between 0 and 1 bars eaten. So the domain yes, and so that since I didn't say a maximum number of cereal bars that you could eat, you can either have 0 or infinity cereal bars. So it's just going to end up being x is greater than or equal to 0. So the range is going to be either 0 calories or more. So it's just going to be y is greater than or equal to 0.